Welcome to EE206 Circuits 1, lecture number 6, SuperNodes. Now, voltage nodes uses the concept of conservation of current. The voltage away from each node has to add to 0. A supernode expands that. If I make any closed path, the current out of that closed path has to add to 0. The reason you do that is sometimes you can't write the node equations or can't come up with n equations, n unknowns. The reason being is there might be a current source, or the voltage source, attached to the node. The current out of a voltage source is whatever it takes to maintain the voltage, and whatever it takes doesn't help in writing node equations. In that case, to come up with the rest of the n equations, n unknowns, I define a closed path, and then sum the current out of that closed path to 0. For example, suppose I have this circuit. I want to find 3 equations, 3 unknowns, write the node equations to find the voltages V1, V2, V3. Now, one equation is fairly easy. It just says that V1 minus V3 equals 5. The second equation isn't too bad either. As at node 2, the current left, down, and right add to 0. Now we're stuck. I can't write the node equation of V1 because I have no idea what the 5-volt source is producing. I can't write the node equation of V3 either. I have no idea how much the 5-volt source is drawing, consuming. But I still need that third equation. To come up with that third equation, that's a supernode. The idea is draw a closed path. For example, here in cyan, I've got a closed path. The current out of that closed path has to be 0, and that'll be I1 plus I2 plus I3. So my third equation will be V1 over 2 plus V2 over 6 plus V3 over 10. That's called a supernode because I'm enclosing more than one node in this supernode. Also note that there are multiple solutions. A perfectly valid supernode would be this one. I'm going to enclose node V1 and V3. In this case, I now have 4 terms. V1 over 2 plus V1 minus V2 over 4 plus V3 minus V2 over 8 plus V3 over 10. I'll have to add a 0. And perfectly valid equations. Once you get your supernode equation, I have 3 equations, 3 unknowns. It's now time to solve. To solve, you group the terms, put in matrix form, and solve in MATLAB. When you solve, you'll get plus 0.96 volts, minus 0.48 volts, and minus 4.03 volts. To verify your circuit, throw it in CircuitLab, and I'll get the same answer. Next, let's look at supernodes with dependent sources. And if you have a dependent source, nothing really changes. I'll just have plus 1 equation. I've got 3 nodes, so I need 3 equations for 3 unknowns, plus 1. I've got this 4th unknown, Vx. So I need to write 4 equations for 4 unknowns. In that case, one equation is just Vx is V3 minus V2. V3 is 4Vx. And V1 equals 12. I now need a 4th equation. The 4th equation is at V2. V2 minus V1 over 2 plus V2 over 4 plus V2 minus V3 over 6 equals 0. Dependent sources don't cause a problem with voltage nodes. Again, I'm going to group the terms, put in matrix form, and solve. If I go into CircuitLab, this is what a dependent source looks like in CircuitLab. The gain is 4. It's 4 times this voltage. If I do a DC simulation in CircuitLab, I get the same answers as before. Now, this one didn't actually have a supernode. If I move that dependent source around like this, now I do get a supernode. Again, here I've got 1, 2, 3 nodes. I need 3 equations for 3 unknowns, plus 1, plus the 4th equation. So the easy parts would be Ix is V1 minus V2 over 2. And notice I have amps equals amps. V2 minus V3 is 5Ix. Again, this voltage is 5Ix. And I have V1 equals 12. That's 3 equations. I need a 4th equation. I can't write the node equation of V1 because I don't know the current on the 12-volt source. I can't write it to V2 because I don't know the current through the dependent voltage source. Can't write it to B3 because again I don't know this current. So what I do is I draw a closed path where I do know all the currents. Basically I want to have resistors or current sources attached to every point on that closed path. Now I can find the current out of this supernode. That'll just be B2 minus B1 over 2 plus B2 over 4 plus B3 over 6 plus B3 minus B1 over 8. Gives me 4 equations, 4 unknowns. 4 equations, 4 unknowns. I group the terms, put it in matrix form, throw it in MATLAB, and solve. And so I should get 12, 9.17, 2.11, 1.41 volts. If you go into Circuit Lab and build it, here this is a current-controlled voltage source, and the current is the current through here. If I click on that point right there in Circuit Lab, it'll tell me that's the current R2 dot node A. So that'll be my dependent source, the current going in from this direction, going right to left. Solve, I get the same answers I had before. So that's supernodes. Basically, I just want to come up with n equations, n unknowns, and in general, I could draw a closed path around here. The current from V0 equals 0. I could draw a bigger closed path. In this case, it was like this guy right here. Current out of that larger closed path has to sum to 0. And that way, that's a generalized form for voltage node equations. Whole goal is to come up with n equations for n unknowns.